dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Welcome to our today's video. In our today's video, we'll see the trigonometric values of 30 degrees, 45 degrees and 60 degrees angles. Okay, here it says consider the isosceles right-angled triangle given below. As you can see here, we have given right-angled triangle, the right angle at vertex C, this point C, and this right-angled triangle is isosceles right-angled triangle. What do you mean by isosceles? We defined isosceles last time. Isosceles triangle is a triangle in which two of the three sides are equal. Two of the three sides are equal. So as you can see here, the side lengths of this AC, which is given by 1 unit, and the side length of this BC is given by the same 1 unit, and the angle at vertex C is right angle. So we call this triangle is isosceles right angled triangle. Isosceles right angled triangle. That means this triangle is right angle and at the same time it is isosceles. It is isosceles. Now we have given questions here. We'll answer these questions based on this isosceles right-angled triangle. So the first question says, calculate the length of the hypotenuse AB. We defined last time hypotenuse. Hypotenuse means the longest side or the side which is opposite to the right angle in this given right-angled triangle. So the first question is, calculate the side lengths of the hypotenuse AB or side AB. So as you can see here, we have given right-angled triangle. So to find the side length of AB or the hypotenuse, we use Pythagoras theorem. So it says the sum of the squares of the two legs is equal to the square of the hypotenuse or the square of the longest side. Now here we have AC, which is one of the legs given by 1 unit. So square it. 1 square plus again the second one, the second side of the other leg is again 1 unit, so 1 unit, but the unit can be in centimeter or meter, so square it, which is equal to the square of the hypotenuse or the longest side, that is AB. So we have side AB here, then we square side AB, applying the Pythagoras theorem. So the first one, 1 square is 1, plus the second 1 square is 1, the same, which is equal to AB squared, the whole squared, AB the whole squared. Now add the two values, 1 plus 1. What is 1 plus 1? 1 plus 1 is 2. Here we have 2 is equal to AB the whole squared. So we have AB the whole squared. So to find the side length of AB, put the two values under radical or take the square root of the two values. We have 2 here, put it under radical, so it will be the square root of 2. Then we have AB the whole squared again, put it under radical, we'll have the square root of AB the whole squared. So the square root of AB the whole squared is AB, which is equal to the square root of 2, it is the square root of 2 units. So the unit is not given here. If it is, it's 2 radical 2 units. If it's given by centimeter, we use centimeter. If it is meter or millimeter, the units you can use. So the first question is, we are asked to find or to calculate the side length of AB, the longest side or the hypotenuse, which is given by square root of 2 units. So this is the side length of AB or the hypotenuse of the given isosceles right-angled triangle. Now let's see question number B. It says, from the properties of an isosceles right-angled triangle, what is the measure of angle A? What is the measure of angle A? Now as you can see here, we have given right-angled triangle plus isosceles triangle. And we know that isosceles triangle, two sides are equal in length, and the opposite angles which are opposite to these equal sides, they are said to be base angles, and those base angles are equal in degree measures. They are equal in degree measures. So as you can see here, we have angle C, which is 90 degrees, the right angle, and the two angles, angle A and angle B, they are base angles of this isosceles triangle. It is right angled triangle, at the same time isosceles. And we know that the sum of the interior angles of a given right angled triangle, not only actually right angled triangle, the sum of the interior angles of a given triangle is 180 degrees. So if this is 90, so the sum of the remaining two angles, that means angle A and angle B is 90 degrees. Their sum is 90 degrees. So we have said that the two base angles are equal in degree measures. So we divide these 90 degrees into two equal parts. That means 90 degrees divided by 2. 90 divided by 2, because as I said, the sum of the two angles, angle A and angle B, is 90, plus this 90 will give us 180 degrees. So we divide 90 by 2. This 2 is the degree measure of the first angle A and the second angle B. They have equal degree measures because the triangle given here is isosceles triangle. So 90 divided by 2 is 45. You can check this, it is 45. So the question here, it says, from the properties of an isosceles right angled triangle, what is the measure of angle A? The measure of angle A is 45 degrees. Not only angle A, but also the degree measure of angle B is 45 degrees. Now you can check. Angle A is 45 degrees, angle B is 45 degrees. Add these two, you'll get 90, and then plus the degree measure of the third angle, which is C, 90 degrees, will give us 180 degrees. Now let's proceed to example C, question C. The question says, are the angles A and B congruent? Yes, we have answered this question under question B. We have said that in a given isosceles triangle, two sides are equal, plus the opposite angles which are opposite to these two equal sides are the same. So the degree measure of angle A and angle B are equal. That means they have equal degree measures, 45, 45. So the answer for this question, are the angles A and B congruent? Yes, the two angles A and B are congruent because they are base angles of an isosceles triangle. But this is a special isosceles triangle, which is a right isosceles triangle or right angled triangle. We call it isosceles right angled triangle. Let us see question number D. It says, which side is opposite to angle A? Now we have angle A here. Which side is opposite to this angle? The side which is opposite to angle A is side BC or side CB. So we say side BC or CB. You can use one of the two, but for the time being, let us use this side BC. So this side BC or side CB is the side which is opposite to angle A. Now let's go to the next question. The next question, it says, which side is adjacent to angle A? Again, for the same angle A, we are asked to find the adjacent side. We defined adjacent side last time as adjacent side is a side which joins the given angle A and the right angle, which is C. So which side joins the two angles? It is side AC. So the side which is adjacent to angle A is side AC, or you can say it now, name it as angle C, side CA or side AC. So side AC is adjacent to this angle A. It joins the two angles A and C, or the right angle C. Okay, the last question, it says, find sine A, cos A, and tan A. We have this right angled triangle. From this right angled triangle, now we have the side lengths of all the three sides plus the degree measure of the angles. So using this relationship between the angles and the side lengths of this given isosceles right angled triangle, we are asked to find sine A, cos A, and tan A. So let's find the values. Assume that this is the isosceles right-angled triangle, which is given by A, this one is C, and here we have B, and the right angle is at C, and the side length, the hypotenuse, is given by the square root of 2 units, and BC is 1 unit, and that of AC is 1 unit. Now, after having this one, we are asked to find sine of angle A, cos of angle A, and tan of angle A. So, using trigonometric ratios that we have seen last time, we'll find sine of A, angle A, that means the angle is given here, which is angle A, sine of angle A, cos of angle A, and tan of angle A. Now let's see, sine of A, which is equal to, how we defined sine? Sine is opposite over hypotenuse. So the opposite for this angle A is the side which is given by BC. So sine of A is BC, which is the opposite side, divided by the hypotenuse, or the longest side, which is side AB. Side AB. Okay, now sine A, that means angle A. What is the degree measure of angle A? We have answered this question. Sine A means sine of 45 degrees, because the degree measure of angle A is 45. So sine 45 is equal to BC, which is given by 1 unit, divided by AB, which is the hypotenuse, that is the square root of 2. Now, to find sine 45, here it is. It says 1 over radical 2. But the square root of 2 is irrational number. So let us rationalize it. That means let us change this irrational number into rational. How? By multiplying the numerator and the denominator by the same number, square root of 2. So multiply this by radical 2, or square root of 2, and then multiply the denominator by the same number, radical 2. We call this is rationalizing the denominator. We are rationalizing, or we are changing the denominator into rational number, so that sine of 45 degrees is equal to 1 times the square root of 2 is the square root of 2, or radical 2, divided by the square root of 2 times the square root of 2. We multiply the numbers using the same radical, so that 2 times 2 is 4. So the square root of, we have radical 4 here, radical 4, the square root of 4. So this is equal to the square root of 2 divided by radical 4, or the square root of 4 is 2. So in short, you can write as sine 45 is radical 2 divided by 2. Now let's see cos 45. Cos 45. Sine 45, as I said here, is the square root of 2 divided by 2. So cos 45. Cosine of 45 degrees is equal to adjacent divided by hypotenuse, A divided by H, the hypotenuse. Now cos 45, as we did for sine 45, cos 45 degrees is equal to, what is the adjacent? The adjacent side for this given angle A is the side which is 1 unit, divided by the hypotenuse, the same, which is the longest side, that is side AB, radical or square root of 2. Again, we have to do the same thing, like rationalizing the denominator as we did here for sine 45. So cos 45 is equal to, cos 45 degrees is equal to, after following the same step here, you will get this radical 2 divided by 2. So cos 45 is square root of 2 divided by 2, like sine 45. Now the third one is tan 45. Okay, tan 45. Okay, tan 45 is equal to opposite divided by adjacent. So tan 45, for these 45 degrees, the same angle which is A, still we are finding sine A, cosine A, and tan A. But angle A is given by 45 degrees here. Again, the same angle A, which is 45 degrees. And then for tan, we have the same angle A, 45 degrees. So tan 45 is equal to opposite. For this angle A, the opposite side is BC or side CB, which is 1 unit, divided by, again, the adjacent for this angle is the side AC or side CA, which is again 1 unit. So that tan 45 degrees is equal to 1. It is equal to 1. But in short, you can find tan. There is a relationship between tan of a given angle theta, which is sine of theta divided by cos theta. Sine theta divided by cos theta. You can use this relationship between the three trigonometric ratios. Tan theta is equal to sine theta divided by cos theta. For example, for 45 degrees, we did here, you can check it. Tan 45 degrees is equal to sine 45 degrees divided by cos 45. So tan 45 degrees is equal to, what is sine 45? Here it is, the square root of 2 divided by 2. Again, divided by cos 45 is here, the square root of 2 divided by 2. So here we are dividing the same number. So the quotient will be 1. So tan 45 is 1, and at the same time, tangent of a given angle theta is the ratio of sine and cosine. So these are the values of sine 45, cos 45, and tan 45. So in the next video again, we'll see sine, cosine, and tangent of 30 and 60 degrees angles.